All right, lesson 1-8. We have 3 learning goals today. Number 1, we're going to learn about combining functions through composition. 2, we'll learn about an inverse function, whether or not it exists. And then 3, we'll learn how to solve for an inverse function when it exists, and how to do restrictions on the domain. That's our goal for today. So we're going to look at compositions and inverses. So let's start with first, what is a composition? A composition is applying one function to the results of another. Mathematically, a function h is the composition of functions f of g if this is true right here. So notice this is the symbols for it. Now, what this means, honestly, let me change it to English words. So that's the math words. You're like, what does that mean in English? This is what it means. Whenever you see that little O there, we're going to substitute. That's what a composition mathematically, if you're going to work through the math, that's what you're actually doing. You're substituting. So what happens is, I'm going to try to use my smartboard here. Let's see if I can do it well. You have the equation. Whoops. Let me go back to red. You have the equation f, and you also have a second equation, g. If you're trying to find f of g, here's what you do. You substitute. Now, what do I mean by substitute? Think athletics. In athletics, if someone substitutes for another player, do both players get to keep playing? No. Let's say person A comes off, person B replaces them. Here's the idea. You see how this looks like f parentheses and then the g of x inside? What's happened is the x gets substituted out. So whatever x you have, or however many x's you have in equation f, they come out. Every x comes out, and in its place, you replace it with the entirety of g of x's equation. So that's how you substitute, and that's why it looks like this. So what did I substitute? I substituted the x's in f, all the x's come out, and the equation g of x goes in this place. Does that make sense? I'll do one more right here. This will be good for your notes. What if it said find f o g? And instead of an x, it had the number 2. Well, here's what you do this time. This time, let's say we started with f. And I'm going to just move this x in there. Okay. And then here's how you would start this time. You would first put g of 2 in, and you would get some value. Now, let's just draw 2 circles over here. So this is g. Here's its domain. Here's its range. You plug in 2, and let's just make up a number. What do you want to say that comes out when you plug 2 into the function g? You get a 4. So that would mean this equals 4. Now what you do is you substitute out this x, and what goes in its place? G of 2, which happens to be 4. 4 would go in, and you would get whatever f of 4 equals. Yep, I can repeat that. Okay. So let's say, let me move this out of here. You're trying to find f of g of 2. What this means is this O means you substitute. You're going to substitute 2 first into g, and then that into f. So you'd come to g. So g of x is, you have whatever equation for g of x. Okay. Well, you say, I don't want x this time. I'm going to substitute in 2. And so you put it in the equation. So on over here, what did 2 point to? 4. That's the answer. So g of 2 equals 4. Well, mathematically, what this says to do is to take your f and substitute g of, substitute g of, well, that's gonna be good. There we go. G of x in there. That's, or now said substitute g of 2n. Well, we know what g of 2 is. What is g of 2? 4. And so instead of g of 2, I substitute in 4. And now you would look at f circles, whatever they are, and you'd plug in 4 to its domain and find out what is it over here. Maybe it's 11. I don't know. And so if that, then the answer would be 11. And you'd say the answer is 11 there. So that's how it's going to work. Now, here, I didn't give you actually any equations to work with. I just scrambled some numbers around. So that's composition. If you were going to think of one word to describe composition, what word do you think you should use to describe it? Substitution. So if you were going to think in one word about composition, I want you to think substitution. That's what it is. So I want to walk you through a couple of examples where we're going to do this. You've probably seen this before in Algebra 2. Whether or not you remembered it's another story. So here are some domain ranges that I actually give you. So here's G's equation. Here's F's equation. We're looking for F of G. Now, what do I actually substitute into first? Like when it's writing F of G, where do I go first? You first plug in the X into G's equation. And from there, you plug that into the results. Let me go back. Remember how it said you apply one function to the results of another function? Okay, we're going to plug in X here and get G's result. And then we're going to plug the results of G into F to get the final result. Does that make sense? Okay. Some of you are just staring at me. It doesn't make sense yet. All right, gotcha. Doesn't make sense yet. Let me show you. So here's G. Let's call this the domain. Here's our range. This is our input. We input the numbers -5, -2, 0, 1, 3. Now, what are the results of those X values? -3, -1, 0, 4, 7. What you do is you take these results and you plug them into function F. Okay, so does -3 have a place to plug into on function F? Yes. So I want you to draw a line from this -3 to this -3. Does -1 have a place to go over here? No. We're going to learn this would get, the domain would get restricted here if we lose this value along the way. Pedro, do you mind taking your headphones? What about 0? Does 0 exist over here? Okay, draw a line from 0 to 0. Does 4 have a spot?
I mean, no.
Does 7?
Yes.
Okay, draw it across. So there's only 3 values, 3 results from function G that can be plugged into function F. So for F of G, here's what that means. For its domain and range, the only values that would exist in this domain are values that can make the trip all the way across. So where did this -3 come from? Yeah, what produced the -3 originally? 1. So 1 is a domain value because it goes all the way across. 1 produces a, what does 1 produce? A 5. 1 produces here a -3. -3 generates across and produces a 5. So 1 becomes a 5. Now these might not be in the order at the end, but I'm just going to do them like this anyways. Okay, where did 0 come from? -5. And what is 0? So -5 produced a 0. 0 got carried over, and 0 produces a 1. That means -5 in the domain produces a 1 over here. Okay, we got one more. Where did the 7, the bridge of 7s here, where did those, what produced this original 7? A 0. And what does the 7 produce in the range of F? 7. So 0 produces a 7. So here's what this means. For this problem, how many original members of the domain were there? How G's domain. How many members of this domain do we have? 5. In F of G, do I still have 5 members of domain? No, but this domain is a subset. This domain for F of G, the domain is a subset of G. The domain will always be is a subset of G domain. So when you do function composition, the domain will always be a subset of the last letter here in the composition. It'll be a subset of that one's domain. Now, where did the range come from? The end result. Where do we get these range values? From function G or function F? G. 5, 1, 7. Where did they come from? F. And they came from the range of F. So this range is always the range is a subset. Whoops, forgot the E. A subset of F's, not domain,
I
F's
mean,
range. There you go. So why am I saying that? I want you to get this. What I want you to get is the substitution works like this. Come back over here with me. You first plug in the x to which equation?
G.
G. So that's where we start. It starts with the domain of G, but where we end is we take the results of G and plug that into F, and we end with F's range. So you substitute from the right to the left. That's how we substitute from the right to the left. So the domain comes from G, the last letter that you see, not ignoring the X. X means domain. That X of G, so G's domain, but it ends with a range of F. Okay, I want to make sure you're following with me. This time I want to do 3 letters. I'm not going to do the circles. I just want you to explain this to me here. I want to see if you're tracking with me. What if you had F, O, G, O, H of X? This one's domain and this one's range. Domain, range. This domain right here will be a subset of what function? I hear H and I agree. Why would it? I can't spell again. Here we go. Be a subset of H's domain. Now, when I say subset, they could be the exact whole domain, and it could lose value. Subset means it's either the entire or a smaller portion. So the domain would be the subset of H, because what would happen is this: the X gets plugged into H, and then from H you would go into G, and from G would go into F. And so what would the range be a subset of? I cannot spell subset to save my life. There we go. If you need to get it so you remember it, then yes. Pause that there for you. Quick test. If the domain of H are the numbers 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The domain here, could it ever be 0, 1, 2, 3, 4? No. Could it be 1, 3, 5? Yes. Could it be 1, 2, 3? Okay, let's go back. What was the domain did I say here? 1, 2, 3, 4, 5. Could this be 1, 2, 3? Yes. Could it be 1, 3, 4? Could it be 1, 2, 3, 4, 5? Yes. Could it be 0, 1, 2, 3? Why not? 0 is not in this one's domain. Okay, let's say the range here is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Tens from 10 to 100. What are some options that could be a range here? Start throwing out some numbers that could be in the range. 10 could be in. 50 could be in. 20 could be in. Could 25 be in? Could 2 be in? No, it has to be something from that one's range. Okay, so you got that down a little bit more? Making sense? Some y'all are too quiet. That probably means no. Let me show you without circles. Let me show you by equation. Here's 2 equations. F is 2x minus 5. G is 3x plus 1. It says first, find G of f of x. So what would I do? Well, let me translate this for us. G of f of x is the same thing as, write this down, please. G parentheses f parentheses x. Now, why is that the case? What we're saying to do here is to plug in x into F's equation and then plug in F's equation into G's equation. So I'm going to take x into F and then F into G. All right. So just to write it out, G's equation is here. What's going to get substituted into, instead of G of x, what goes inside of x? We're substituting in f of x. Well, we don't have to do anything with f because it already has f of x there. What is f of x? Okay, so this x right here is going to be substituted out, and it's going to be replaced. So this x right there is going to be replaced by, you just said it, say it again. 2x minus 5. Okay, I'm gonna write it out one time in full long form so you can look at it. So this would mean that g parentheses f of x. So I'm substituting this x out and f of x is replacing it, would equal 3 times parentheses instead of x, instead of 3x, what does it equal now? 2x minus 5 plus 1 outside the parentheses. So let's simplify. What does it mean when you have a number in front of parentheses? Multiply. Parentheses always mean multiply. So what is, I'll distribute here, 3 times 2. I should say 2x. Good, y'all corrected me. 6x, and then 3 times negative 5. And then we add 1. 6x negative 14. All right, good. That would be g of f of x. To write it in their form, this is, both forms are acceptable. This is the, I guess you call it proper form of writing it, is with these brackets. You would say that's 6x minus 14. Now, if you're looking at it going, what in the world did we just solve for? Well, I'm going to show you. Pick any number whatsoever. I recommend you pick a simple positive number.
69.
I heard 2. I'm going to go with 2. Okay. What I'm going to do here is I'm going to plug in 2. What if this said g of f of 2? What if it said that? Where would I plug in the 2 first?
In the equation.
In the f. Okay. What is, I'm plugging in a 2 here. Okay. We're just doing an experiment. What's 2 times 2? 4. And then you would minus 5. You would get negative 1. Then you would take that result, the result of negative 1, and you plug that into g. So if I plugged in negative 1 here, it would be 3 times negative 1, negative 3 plus 1, negative 2. All right, so we plugged in originally a 2, and we ended up with a negative 2. Here's what we got here. If you plug in a 2, this should jump straight to the answer. What is 6 times 2? 12 minus 14? Negative 2. That just made the shortcut for us. That's what this equation did. It shortcutted the composition. That's what we just did just now. Okay, let's do it again. Do you think we'll get the same answer if we do f of g?
No.
Oh, y'all say no. Let's find out. So f of g could be translated as f parentheses g of x. Let's see if we get the same thing. So what's substituting into what?
So g substituting into
Okay, so instead of saying f of x, what's going to replace x?
it will be f of 3x plus 1.
G of x will go in. So if f of x is 2x minus 5, we're going to substitute in for this x. And if there were multiple x's, you do it for every single x. What are you going to replace this x right there with? With g's equation, which is 3x plus 1. So f of g of x will equal 2 times 3x plus 1 minus 5. Sit up off your desk. Let's distribute here. What's 2 times 3x? 6x plus 2, and then we will minus 5. So what is f of g of x actually going to equal? 6x minus 3. Now, is that the same as before? Composition is not always commutative. Commutative means you can change the order and get the same answer. It's not commutative. Sometimes you will have equations that work that way, but not always. Most of the times they will not. Just do a quick test. You can plug in the number 2 to see if you get negative 2. We don't. What's 2 times 6? 12 minus 3. We got 9 this time. We did not get negative 2 like we did there. Okay, so you've seen me do a couple of these. I want you to take some time to find f of g of 1. Find f of g of 1. First DOL. Let's look at example 3 now. It says, given a function f and function g, find g of f and state its domain. Okay, so remember, g of f. Let's see if we can remember. The domain will be a subset of which one? Because x goes into f, and then f will go into g. That means the domain will be a subset here. The domain will be a subset of f, and the range would be a subset of g. The range will be a subset of g. Okay, let's work this through. So when we go to write this, we go to x first. Is f of x is all reals? Is this equation all reals? No, because look at the board. There's 3 rules. What are you not allowed to do in math? Just read them off. What are the 3 things you can't do?
You cannot
You can't divide by 0. What else?
cannot take even root of a negative.
Even root of a negative number. And
You cannot take a logarithm of a non-positive.
that's right. You can't take a logarithm of a non-positive number. Okay, what do we have going on? And we start with f. What do we have going on in f? Square root. What are you not allowed to take a square root of? Negative number. So that means x minus 3 cannot be negative. What's it translate into a math symbol? What does it mean if it cannot be negative? Oh, that's a good thought as absolute value. It's actually written a different way. Think of it in comparisons to 0. If you can't be negative, what can you be?
Positive.
You can be positive. What else could you be?
0.
0. So you'd say x is greater than or equal to 0. That's how we do the inequality. You do your domains with inequalities based off of how it compares to 0. Okay, now let's just solve it. How would you solve?
So x can be greater than or equal to 3.
Add 3. X is greater than or equal to 3. That's our domain. That's g o f of x domain is that x is greater than or equal to 3. Now, how do I know that? Because let's plug in our equation. We're trying to find f of g of f of x. So I would take the g of equation, and what am I going to plug in place of x in g's equation? Now, remember, x substitutes into f, which we don't have to do. It's already done. That is f of x. And so what substitutes from here? F goes into g. So I'm going to substitute f's equation in here. So anywhere I see an x, what's going to go in its place? No. Anywhere in g's equation I see an x, what do I put in?
0.
What's f's equation? Of x minus 3. That's what's going to go in there. So here's what g of f. So g of f of x equals 2 parentheses. Instead of that x, actually I don't need to use a parenthesis because I have that square root to work with. I'm just going to put the square root in place of x. The square root of x minus 3 squared minus 5.
Square root of square root of square.
Ah, great. So we can reduce this is what you're saying. The square root and the square cancel each other out. So that's equal to 2 times x minus 3 minus 5. Now I added the parentheses because that's multiplying. That 2 was multiplying, and multiplying has to distribute. So what do we get now? Get up. Getting tired of this. 2x minus 6 minus 5. That was from distributing. 2x minus 11. That is, I'll write it proper now, g o f of x. There's our equation right there. And here's our domain. Now what's interesting is when you look at this equation, does it look like, the equation looks like it should be all reals, does it not? When you look over here, do you see any more divisions or any square roots? No, so you would think it's going to be all reals, but the domain is a subset of this. It can't be all reals. So that was from F. That's F's domain here. F's domain was here. It couldn't have been all reals because it was already cut off to begin with. Now, technically, I need to throw out there, if when we plugged it into G had division, we would also need to cut off that it could not be equal to 0 as well. We'd have to take out the value of being equal to 0, but that wasn't the case this one. Okay, I got one more composition before we move on to inverse. This DOL, given f of x equals 2x squared minus 30, and the graph of G, find G of f of -4. G of f of -4. Now let's take a look at an inverse. An inverse relation is an expression that will map a member of another's relation back to its domain. Said another way, an inverse function is a function that undoes the actions of another function. So you'll say at the start of the lesson opposite. Mathematically, a function g is the inverse of a function f if whenever y equals f of x, then x equals g of y. Here's what that means. Throw out an x.
1.
Okay, let's say you put in an x value of 1 into f and it produces a 5. Then that would mean if you put in a 5 here, just keep your y's. Don't think of it in terms of like a graph. If you plug in 5 here, you get a result of 1. Wait, let me say that again. What an inverse is if you plug in 1 here and you get 5, the inverse would mean if you plugged in 5, you would get 1. That's all it's saying. That's what makes an inverse. Shown another way, so using composition. If you have g of f of, if you took f of g, you would get x. If you took g of f, you would get x. If your composition leaves you with x, meaning it cancels everything except the that x that you plugged in to start with, then it's a inverse. If the inverse of the function is of f is a function, you use this symbol, f -1. That means inverse right there. Okay, that means the inverse is a function. All right, with that, we can use a horizontal line test. And here's why we use it. Let me go up here. To solve for this, we're going to switch x and y. Actually, I'll leave that in here that I had here. Notice what happens is you switch x and y. Let me say that. Switch x and y. So why do we switch x and y? Because to find an inverse, we got to do the opposite by equation. Opposite by equation. The way to find out that opposite equation, you switch x and y and solve for it. That's how you do it. So therefore, I have it for you in a second. Therefore, when you look at a graph, if you want to know, see, here's the original function. You see how it just has f? Does it have f -1 or does it just say f? This is talking about the original function. What you would do is you would test it with a horizontal line test, not a vertical line test, a horizontal line test, because this would tell you if its corresponding inverse would be a function. Because how do you get to an inverse? What do I just write down the previous slide? You switch x and y. And so once you switch x and y to find the inverse, what happens is this horizontal line becomes a vertical line, because it looks like an x-axis becomes a y. Okay, so let's pick up. Here's the steps for finding an inverse. They walk you through. I'm just going to do them. You'll have these for your notes. So first, we'll start just like I did with compositions. If you're looking for an inverse, find g -1 if it exists. Well, how do you know if it exists? How you know if g is a function is you look to see if there's any repeating x's. Does this have any repeating x's? No. That's basically what the vertical line test does. Did I have any repeating x's here? No, that means g is a function itself. Well, if you want to know if its inverse is a function, you look for repeating y's. Do I have any repeating y's?
No.
No. Therefore, no repeating y's. Whoops. Since there's no repeating y's, no repeating y values. What do I mean by that? It would be like two arrows coming to the same number. Since there's no repeating y values, g will have an inverse function. So I'm going to put g -1 of x. And so here's how g negative 1 of x would look. It would have the same numbers. You switch the x and y. So if this is the domain and this is the range, you switch the domain and range. The domain and range over here get switched. So it would be negative 3, negative 1, 0, 4, 7. Now, just to make it easy, what will negative 3 map to?
1.
1. Actually, I'm just going to go ahead and write these out here. Negative 5, negative 2, 0, 1, 3. Okay, now they have this written in as its range. Now y'all tell me, what does negative 3 get mapped to? Negative 3 gets mapped to 1. What does negative 1 map to? 0. Nope. 0 goes to negative 5. 4 gets mapped to 3. And 7 gets mapped to 0. Notice over here, there's no repeating x's now. Since there was no repeating y's here, there would be no repeating x's on this one. So this would be a function. And something you need to know is not only is this, so we call this one-to-one since both g of x and g negative 1 are functions. Delta math will ask you if it's an onto function. As far as I know, AP doesn't care, but for your sake of your homework, this is an onto function because there's no blank numbers. Also onto since every value is used.
What is it? 1 dash to negative 1?
1 dash. No, this is 1-to-1. Let me write the words. 1, 2, 1. That's what they'll call it. Since both g of x and g negative 1 are functions. Also onto, it's an onto function because everything's used. Everything has something onto it. Okay, come over here. Here's f. Now, is f itself a function? Is every x used one time and only one time?
Yeah.
Yes. That means f itself is a function. But if I want to know about its inverse, you would look over here. Is each y used one and only one time?
No.
Now, there's an extra one, but on delta math, they're going to say this is still a function, just not onto. Okay, they'll still call it. Now, in my class, I don't think you're going to see it this way. But because they're used once and only once, they will call it an inverse function. So we're going to do this for delta math. Okay, so let me put delta math here because that's how they do it. For delta math, they would say this is 1-to-1. 1, 2, 1. Since each value used a maximum of one time. But not onto. Why is it not onto?
It's not every value.
Yeah. Which value is not used? Okay. So on this one, the inverse, what would the inverse look like? I would not put the 10 in. I'm not going to put the 10 in since 10 isn't used. So I'm going to write down 0, 1, 3, 5, 7. And the range would be -5, -3, 0, 1, and 7. Notice I just switched the x and y. That's all I did. This was the domain. This was the range. It's now a new domain, a new range. So what happened is I switched them. I'm going to leave out the 10 though. So what does 0 map to? What does 1 map to? What does 3 map to? What does 5 map to? What does 7 map to?
7.
7. And I'm not going to include the 10. Okay, so there it is by circles. Let's see it by equation. It says, is the inverse of this a function? Why or why not? Well, I would do a horizontal line test. So this is a function itself. Is the inverse a function? Let's find out. So what does x squared minus 3 look like as a graph? Use the leading term. What's our leading term? X squared. What does x squared look like? A parabola. Okay, parabola facing up. So it looked like that. Now with the transformation, what would happen if it was minus 3 on the outside? It's shifted down because it's not on the inside, it's on the outside. I would shift it down 3 like that. Okay, so now use a horizontal line test to test the inverse, because the inverse you have to switch x and y. Would it pass the horizontal line test? No. The inverse is not a function. So the x squared itself is a function, but the inverse is not a function. The inverse is not a function since the original function fails the horizontal line test. I'm going to put HLT. What does that stand for? Horizontal line test. Very good. Now it says find the inverse function or relation. So if it's not a function, guess what it is? It's a relation. So we're going to find the inverse relation. So how do you do it? Here's how you start. You start with the original function. You make the f of x be a y. Like this. So here's our original. All I did is I substituted in y for f of x. And now to find the inverse, you switch x and y. So the inverse in improper form would be x equals y squared minus 3. It said improper form. That's not what they call it. I'm lost on the word. I'll come to me in a second. But we have x equals y squared minus 3. Now we solve for our y. So to solve for the inverse, you switch x and y. That's step 1. Let me write that over here. Switch x and y. And what now? Step 2, you solve for the new y. Solve for new. Solve for new y value. So that's what I'm doing now. So how could I solve for y here? How do I get this y isolated? Let's add 3 to both sides. So it'd be x plus 3 equals y squared. One more step. Square root both sides. Now, whenever you add a square root that's not originally there, it needs to come with a plus or minus. Until we get to unit 3, anytime you add a even root that's not originally there, you need to add a plus or minus with it. Anytime the root is even, it comes with a plus or minus. So that means now that we have y by itself here, y equals plus or minus the square root of x plus 3. That would be our equation there. Now, if it were a function, you would substitute back into the symbol f negative 1. This is not an inverse, so I'm not going to substitute anything. I'm going to leave it right there. And a lot of times step 3 will state any restrictions on the domain. This one, state restrictions. We didn't have any restrictions though. If you had restrictions, it would start it up here. So we're not restricting. If necessary. We're not restricting though, because it didn't have anything up there. Okay, so let me show you. I'm going to go to the. Do I have time? Okay, there. The function was y equals x squared minus 3, right? That's what it was. So the inverse you can on Desmos, you don't have to solve it. You can let the calculator do it for you. X squared minus 3. Even the Inspire could do this for us. I'd have to show you how to do it to be quicker. I just wanted to go ahead and graph it. So there's the graph. I want you to look at it. Is the inverse a function? Is this blue graph a function? Does the blue pass the vertical line test? Does it? No. And if you're wondering, why do I have to have that plus or minus? Remember when we solved it, we got plus or minus the square root? Because if it was only the positive square root of x plus 3, does this graph perfectly, it does overlap, but does it perfectly match the blue?
Yeah.
No, the positive only gets half of it. You need, let me see, how do I copy that? There you go. You would need the negative half as well to get a full parabola. See, I need the positive square root and the negative square root to make it be a perfect inverse. An inverse switches x and y. What does an inverse do? Switches x and y. All right, back over here. Example 6. It says if the domain of this equation is restricted to 6 to infinity, would its inverse be a function? Why or why not? Okay, help me out here. If we wanted to graph this leading term, what we know its shape. According to its leading term, what shape will this take? It's a parabola. Now we can find out more about this parabola if we apply a little math. How could we simplify this? And you need to know how to do this for the test, by the way. You see a trinomial. How can you simplify a trinomial? Does it have a GCF? Let's do X method. What? So it didn't have any. X method. What are factors of 36 that add up to be negative 12? Negative 6, and that means our equation we could rewrite as x minus 6 squared. Well, what does that tell us? That tells us which way to shift my graph. Which way does this graph go if it's minus 6? Inside lies. Oh, I just locked that. Whoops. Unlock. I need to send this to the right 6 units. So this graph, it says to restrict it. And the domain is restricted. The domain, that means x values. The x values are restricted from 6 to infinity. That means we don't pay attention to this part of the graph. This part is restricted. So is the inverse a function? Does it pass the horizontal line test now that I scratch out that part of the graph?
Yes.
Yes. What'd you say?
So
when it says restricted, it tells you what exists, not what does not. It tells you the graph will exist from 6 to infinity. So I cut off the other parts that's less than 6. So the inverse f-1 will exist since f of x passes which test? Not the vertical, the HLT, horizontal line test. Now to find the inverse function, it'll be a lot easier if I use this equation there. So the original is y equals x minus 6 squared. So the inverse would look like, how do you find an inverse?
Switch the y.
Switch the x and y. And we solve this. What's your first step? Yeah, how do you get rid of the square? Now, typically we need a positive or negative. But in this case, I won't. Do you know why? Because this restriction, I only want the positive side or the negative side. Which side do we keep? Positive. I only want the positive square root this time. So it's square root of x equals y minus 6. And finally, we would add 6 to both sides.
It will be the square root of x plus, let's say, equals 1.
Yep, and you can change it to f-1 this time. And this one, the range would be 6 to infinity. The domain would be 0. Talked about that. That's because I'm looking at the range over here. The domain and the range, they switch. you're wondering how do I know that? It's because over here it's an inverse. The domain was 6 to infinity, and the range was 0 to infinity. So the domain range would switch.